fourth and final guided practice. It says if a gas has a volume of 750 milliliters at 25 degrees Celsius, so milliliters is volume, degrees Celsius is my T1. What would the volume, so I'm looking for a V2, of the gas be at 55 degrees Celsius, T2? Now, one thing you want to always make sure that you do is you want to check to make sure that all your units are like they should be. Right now, I have my volume in milliliters, and we like to have our volume in liters. So in order to make it liters, I need to convert it. And what I'm going to do is I'm going to take the decimal place, which is currently behind the zero. Put it there. And you need to move it 3 times to the left. 1, 2, 3. So this becomes 0.750 liters. I'm going to go ahead and I'm going to cross that out because I don't need it. All right. I'm just going to write it over here. So our V1 equals 0.750, right? Now our temperature must be in Kelvin. Right now it's in degrees Celsius. So in order to get it to Kelvin, we need to add 273 to it. So I'm going to do 25 plus 273. And we get that our T1 is equal to 298 Kelvin. Same thing with this temperature. You must add 273 to this, and you get T2 is equal to 328 Kelvin. All right, so all that I'm missing now is my V2. So go ahead and we're going to find our equation. Again, we have 2 temperatures and we have 2 volumes. So we can use the P1 V1 over N1 T1 equals P2 V2 over N2 T2. We're going to circle what we have, right? So a P1, there's no P1 up here, so we're going to cross that out. We have a V1. N1 we do not have, but we do have a T1. Over here too, no P2, we have a V2, no N, but we do have a T. So therefore our equation becomes V1 over T1 equals V2 over T2. All right. Now to plug in our numbers. In place of V1, we have the 0.750 over the T1, which was 298, equals my V2, which is what I'm looking for, X, over T2. All right. When our equation is set up like this, in order to solve it, we're going to do the butterfly method. We multiply these two and divide by what's on the outside. And we get that X is equal to 0.826 if I am doing 3 significant figures.